So hello, welcome back to my video. This video will be on classification, and this is my first classification model I've ever done. And this will be the first on my project because other projects are just on data analysis, exploratory analysis, and others. But this will be my first machine learning model I've created as a data analyst. So I will have to explore my data first because I have to pre-process it, do some changes on the data, select features. That's why I named it exploratory analysis. So I'll first of all do my exploratory analysis, so I can select my features. The relevant one I'll use it, the irrelevant one I'll filter it out, and then choose the right one for my model. So this is what I'll be doing now on this first part. And on the second part, I'll now show you the regression. I'll show you the classification model. How I was able to get it working. Now the data I'll be using is this data. If you have watching my previous video, you see this data here. This data this is the hospital data. So if you're watching my previous video, you see it. I scraped it from a healthcare agency site in Nigeria. This is a healthcare I don't really know, but it's just a healthcare organization for Nigeria. So without too much explaining too much, okay, let me just get started. Let me first of all import pandas, then I'll save it on data and print it out. Now this is the basic thing I normally do when I want to use pandas to work with my my data set. So I'll first of all import it. I'll save it. I'll read it to a CSV file and save it to I'll read the CSV file to a variable. Then I'll create a copy of it because I don't want to manipulate my original CSV file. So I could also, in case if anything goes wrong, I could also get it back. Now, okay, it's loading. Okay, done. Okay, now I'll say I have to check the correlation. Now, when you are dealing with machine learning or you are trying to select your features, most of the time it's advisable to select features that are correlated with your target variable. Now your target variable is what you'll be predicting, while your features is just like him say, the predictor, or what you use to make the prediction. So in this case now, our target variable, because this our target variable is the ambulance service. That's our target variable. So we're trying to check if a particular facility in Nigeria provide ambulance service or not. So that's the main idea of this project. So it's just ambulance predictor. You see the title is there, so I can't really. Okay, yeah. So I check the correlation between the categorical variable and the target variable. So now I'm setting the threshold with a p-value of 0.05. Now once it's above the 0.05, I will not use it. I will not use the feature. I mean, this p-value just is statistical significance. Okay. And once it's below this, I will reject the null hypothesis of what independence, which means this is just a statistical term. I will have to explain it here. It's just a little bit of bigger explanation over there. So I just have to focus on the main part for now. So okay, let me run this now. I will have to run it for all features. Now I'm running for the state feature. Let me check the correlation between the state and ambulance service. So that's what I'm trying to do now. I'm using the chi-square. Now this chi-square is what you can use to check the correlation between a categorical variable, like two categorical variables, because actually our target variable is a categorical variable and this is also a categorical variable. So I'll be checking out the p-value is 5.3 this raised to power. Remember, when you see this earlier, don't follow the mistake of thinking that this 5.3 is not actually 5.3. This is 0.00 because you're having this is lesser than 5.3 because you're having minus, which is 0.0000 continuously. I don't have to go, but once you see this e, which is raised to power minus, this e is just like let me say in mathematics 10 raised to power minus 136. So we'll be using this because it makes sense. That's also I'll use this one. It makes sense because it's lower than our p-value, so it's still within our threshold. So let's go for this one. This is the ownership. Okay, this one too minus. Okay, it's within our threshold too. I'll use it too. Okay, let me run this. This one I will not be using this. This is above our threshold because of as you can see 0.01, which is above 0.05. So we'll not be using that categorical variable. Okay, let's check this out. As you can see, okay, this one is, we'll be using this registration start to, we'll be using it because it's minus 52. Raised to power minus 52, so 0.000. So I don't continue saying 000. Yeah, okay, let's check the license status. It's the same thing, we'll be using it too. Okay, let's check the inpatient. Now this one, we'll not be using it. The same for the also the outpatient too, we'll not be using it too. Let's check for the on-site laboratory. The on-site laboratory 0, we'll not be using it too because above 0.05. Even these two above 0.05 too. So let's check for the local government. Wow, this is fantastic. We'll be using this, but later on I will show you this. There are some I will not be using even though their p-value is lower than 0.05, but I'll give my reasons later on in the video. Let's check this one to word. Okay, minus 47, that's cool. Let's check operational days, minus 103. Okay, these two minus 178. Okay, then this, we'll not be using this as usual. So now we are done with the categorical variable. Let us check the numerical variable. Now we're not checking the numerical variable, we're going to check the correlation between the numerical variable and the categorical variable. Now remember, the first one was, this upper ones was categorical variable and categorical. So since we'll be dealing with numerical variables and target variables, we will not have to use yes or no. So that's why I did this. I use this, so we don't have to use the yes or no for the ambulance service. We don't have to use 1 and 0 because the metric, or let me say the what we'll be using to measure the correlation between numerical variable and target variable is actually it actually works with numbers. So using letters to make it run into an error. So this is the threshold we're using. So 0.00 to 0.19 will be very weak, and others too. So and a p-value lower than 0.05, we'll use it for the model. So this is an error before, so I fixed that. I have to run it. I think it will work now. Okay, over here now, as you can see, the p-value is also lower than that. Okay, but this has a weak correlation, very weak. It's a very weak correlation. Okay, we'll consider that later. Let's just run others to verify. This one, the same thing, weak, is a weak or very weak correlation, sorry, but the p-value makes sense. It's one 0.25. This one is weak correlation. Okay, not that bad, but the p-value doesn't didn't meet up, so we're not even using that. This again too. Oh, very weak correlation. Then for the pharmacy technicians, the p-value doesn't make sense. Sorry, it didn't meet up. Sorry, it doesn't mean that it doesn't make sense. It doesn't meet up. Even these two, even the nurses, labs, most of them, their p-value are not meeting up. As you can see. Okay, this one is p-value meet up. Nurse midwife, 0.7. The p-value didn't meet up. The p-value does meet up. I forgot most of them. Okay, this one is 0.27. 0.27. Stay under weak correlation. So this one weak. This one is very weak. Sorry, this one is also weak because 0.33 is also weak correlation. So most of them over here are weak correlation. I will show you how I will make my selection at the end of the day, but let me just show you others too. So okay, so it's also weak correlation. I think that's very weak, sir. That is not even weak. Very weak too, but have a good p-value. Very weak too. Very weak. Okay, let me just run others because there are many of them here. Okay, after that I gave this note. I say, okay, for the numerical column, these are the column we will be using. So these are the column: doctors, pharmacy, dentist, nurse, lab scientist, midwife, and others, and bed, because they are more reasonable than others in as much as they are points by serial correlation are all weak based on those our threshold. Now the reason I chose those ones are because of the p-values. They have good p-values. Like, okay, let me just show you doctors. Okay, let's check out doctors. Okay, doctors. That's a good p-value. I think pharmacy too. I chose that. No, I don't choose. I didn't choose pharmacy. Okay, I chose pharmacy. Okay, I chose pharmacy. So I chose doctor, pharmacy. Okay. This one I chose because of he has a even the statistical significance is not up to that, but at least it has a little bit of correlation, but it's weak. So the main idea of this is just to check their correlation. Now there are some that are very weak, but I chose some of them that are weak and some that has good p-value. So at the end of the day, most of them are weak. So using some if as you can see, this one is even minus. Most of them are weak. So I just select those which will be actually relevant for our model. I didn't do it based on p-value, because if I was doing it based on p-value, then pharmacy could have not be here. So I just chose those weak. Those ones, though many of them are weak, I just chose the ones that are more reasonable for our model, because even though I decide not to add them, it could affect our model, because something like doctor, pharmacy, dentist are needed in a facility. So not adding them over here will not make any sense at all. In as much as the what we use to measure them is showing weak, but at least I use them because they make sense in the model. Now, therefore, the category variable, we'll be using these ones. We'll be using states. Now, I chose this one based on their p-value. And secondly, I dropped some, even though their p-value was good. The reason for that is that, because normally, when you are trying to measure correlation, you don't use only the p-value. You don't use all the p-value. The p-value is important, but you don't use only the p-value. So over here, states, I chose states, ownership, registration status, and operational days. Now, the reason for this is I removed others because their p-value are greater than 0.05, and some is not relevant for this project. Thus, it's important. It doesn't make any sense to have state and local government. So I remove local government and leave state. And when it comes to registration status, I leave registration status and removed license status. So it doesn't make sense to have both of them, because both of them are also the same thing. A facility that is registered is already licensed. So having both of them in my model doesn't make any sense. So I run this to keep the ones I want. So these are the ones I'll be using for the machine learning module. And then I saved it. So I'll not have to save it again. I've already saved it already. So thank you all. So in the next one, we'll be talking about the module itself. So thank you.